Welcome to The Explainer. Have you ever stopped to think about how your favorite app, or any computer program for that matter, remembers your username or keeps track of your shopping list? Well, today we're pulling back the curtain on the digital containers that make it all possible in Python. We're talking about its built-in data types. I mean, really think about it for a second. How does a program actually hold on to a piece of information, whether it's a simple number, a person's name, or a whole collection of your favorite songs? In Python, the answer is pretty elegant. It uses these things we can think of as data containers. And the clever part is, each type of container is specially designed for a very specific job. All right, so let's start at the very beginning, with the simplest containers of all, the ones that are built to hold just one single piece of information at a time. First up, we've got the numeric types. You can just picture these as tiny little labeled boxes, each one designed to hold a single number. It doesn't matter if it's a whole number, what we call an integer, like 5, or a decimal, a float, like 2.0. It even works for complex numbers. And here's what's so cool about Python. It's smart. You don't actually have to tell it, hey, this is a whole number, or this is a decimal. It just looks at the number you give it and automatically figures it out. That little bit of magic makes coding so much faster. Okay, so we have numbers covered. What about text? For that, we have a container called a string. The best analogy is a clear, sealed display case. You can see all the characters inside, perfectly in order, but because it's sealed, you can't change what's in there. In programming, we call this special property immutable. So, holding one item is great, but what happens when you need to store a bunch of things together and you care about the order they're in? Well, for that, we need to move on to collections. The first, and maybe most common, type of collection is a list. Honestly, just picture an open-topped box. You can throw new things in, take things out, and rearrange them whenever you want. It's totally flexible, or as we say in Python, it's mutable. And this flexibility is really what makes lists a powerhouse. I mean, they can hold anything, numbers, text, you name it, all in the same box. You can grab an item just by knowing its spot in line, and of course the box can get bigger or smaller as you need it to. For instance, look how easy this is. You can use a simple command like append to just add a new item right onto the end of your list. It's this ease of changing things that makes lists one of the most used tools in all of Python. Now, the other kind of ordered collection is something called a tuple. It's a lot like a list, but imagine you took that open box and vacuum sealed it shut. Once it's sealed, that's it. You can't add, remove, or change anything. Just like a string, a tuple is immutable. So this is the absolute crucial difference: mutability. Lists are your go-to when you know your collection is going to change over time. Tuples, on the other hand, are for data you want to protect and keep constant. Because they can't change, they're often faster and more efficient. And you can use them in special situations where Python needs to know the data is unchangeable, like for keys in a dictionary. All right, let's level up. We're now going to look at two more advanced containers. These aren't just for storing items. They're specially designed for finding them really, really fast. First is the dictionary. The best metaphor here is a filing cabinet. Think about it. You don't sift through every single file to find the one you want. No, you look for the label on the tab, the key, and that takes you instantly to the folder you need, the value. So in this example, name is a key. It's the label on the file tab, and it points to the value Alice. Same thing for score. That's another key, and it points to the value 95. Every piece of info has its own unique label. And this, right here, is what makes dictionaries a complete game changer. You just ask for the key, in this case name, and you instantly get the value Alice. There's no searching through a list. It's incredibly efficient. And finally, we have this set. My favorite way to think of this one is a bag with one very special rule. It only holds unique items. If you try to toss something in that's already there, the bag just ignores it. A set doesn't care about order, which makes it lightning fast for one specific job: checking if something is already in the collection. Think about checking if a username is already taken. A set is perfect for that. Okay, so we've looked at quite a few different types of data containers. That brings us to the big question, right? How on earth do you know which one to use?
Well, this table really summarizes our whole digital toolbox. Choosing the right container is what separates good code from great code. You just have to ask yourself a few simple questions. Is this data going to need to change? If the answer is yes, a list is probably your best friend. Do I need to look things up instantly using a unique label? That screams dictionary. Or maybe, do I just need to know if an item exists in a group of unique things? That is a job for a set.
And as the source material points out so well, using the right tool for the job, like a dictionary for those fast lookups, is absolutely essential. It's the key to writing code that's not just effective, but also efficient. It's all about working smarter, not harder. So here's the real takeaway. These data types, they aren't just some abstract theoretical concept. They're the actual boxes, the bags, the filing cabinets that you are going to use to build things in Python. Understanding what they are and when to use them is the critical first step. So the only question left is, what will you build with them?